When we talked about the method for designing the riprap channels, the tractive force method, we talked about what was called the dimensionless critical shear stress. This concept was first discovered by Shields, who was a German physicist. And Shields, through his research, came up with this particular diagram, which has come to be known as the Shields diagram. The vertical axis is called the critical dimensionless shear stress. And you'll notice on this particular one it's called theta sub c. On the reference by Sturm it's called tau star sub c. So you'll notice the horizontal axis is what's called the boundary Reynolds number. And the curve, you notice at first goes down and then backs up, starts going up, and then finally reaches a constant value at a Reynolds number of approximately 400. And there it's constant for larger Reynolds number. Now, the next of the Shields diagram is a little bit different. The horizontal axis has different units now. It has the dimensionless sediment size, but the dimensionless critical shear stress is shown on the vertical axis. And you can see there are three curves here. The green one was the original Shields curve, and it's called initiation of motion. This is when the particles along the wall or the bottom first begin to move. You can see then the initiation of motion curve that was put in by Soles in 1997 is very similar to the original Shields. Also, there was another curve put on at this point, and it's called the initiation of suspension. So not only are the particles moving, but they're actually being carried along by the water. Another Shields diagram is very similar to the previous one. It's based on the dimensionless particle size, and also then that the critical dimensionless shear stress is shown on the vertical axis. This particular slide gives an equation for the curve and also then the standard equation for the dimensionless particle diameter. This particular slide tries to show it all. So you see the current Shields parameter again is the vertical axis, which is the critical dimensionless shear stress. And this particular slide again has the dimensionless grain diameter, which the equation was shown on the previous slide and we will be talking about shortly. All of these Shields diagrams were obtained from images on the internet, which are readily available. This one shows a more diverse attempt to categorize the various types of movement. You notice once again, even though it's a different symbol, it is the critical dimensionless shear stress on the vertical axis. The horizontal axis is the dimensionless sediment particle diameter. So you'll notice there are 7 curves plotted on this one with the respective data points where they have been measured. And they have the various categories, starting with the occasional particle movement at some locations, and finally getting down to what they call general transport, where you're actually forming ripples on the bottom of the channel.